Section 5.1 Probability Distributions. A random variable is a variable that has a single numerical value determined by chance for each outcome of a procedure. A probability distribution is a description that gives the probability for each value of a random variable. It is often expressed in the format of a table, formula, or graph. A discrete random variable has a collection of values that is finite or countable. Discrete random variable can be the number of pencils or the number of baby girls. A continuous random variable has infinitely many values, and the collection of values is not countable. For example, a continuous random variable can be the body temperature, or it could also be how heavy a person is. Probability distribution requirements. Every probability distribution must satisfy each of the following three requirements. First, there is a numerical random variable x, which means your x must be in number, not category. X must be quantitative, not qualitative. Second, the sum of all probabilities must be equal to 1. Third, each of the probability must be in between 0 and 1. Example 1. Let's consider tossing 2 coins with the following random variable. X is the number of heads when 2 coins are tossed. The above x is random variable because its numerical values depend on chance. So I'm given a table. This is the number of x's, which is the number of heads. 0 head, 1 head, 2 heads. P of x, that means it's the probability when x is 0 equal to 0.25. Probability when x is 1 is 0.5. Probability when x is 2 is 0.25. And I want to know if this table is a probability distribution. In order to be a probability distribution, it needs to satisfy 3 requirements. The first one, x must be numerical, 0, 1, 2. The second requirement is that the sum of all p of x must be 1. And the third requirement is that each of the probability is in between 0 and 1. Therefore, this is a probability distribution. We can also graph the probability distribution where we have x on the horizontal and probability on the vertical axis. When the number of head equals 0, the probability is 0.25. If the number of head is 1, the probability is 0.5. And when the number of head is 2, the probability is 0.25. Example 2. Hiring managers were asked to identify the biggest mistakes that job applicants make during an interview, and the table below is based on their responses. Does the table below describe a probability distribution? I'm given a table with x representing the mistake that applicants make. P of x is the probability of each mistake. And they're asking me if this table represents a probability distribution. First, x is not numerical. It violates this requirement, so this is not a probability distribution. These are the parameters of probability distribution. First, we have the mean, which is the sum of x times p of x. Variance, sigma square, which is the sum of x minus mu squared times p of x. Standard deviation, which is the square root of a variance. Example 3. I'm given this table and the question is asking me to find the mean, the variance, and the standard deviation. In order to do this, I am going to use StatCrunch. If you're working on a homework problem, you can always import your table into StatCrunch. Now I want to input a table from my example into StatCrunch. I can click on StatCrunch and click here. I am going to enter my table in here. This is my probability distribution. I have x in here and p of x in here. I am going to click on Stat, Calculators, and choose this one. For values, I choose x. For weight, I choose p of x. Compute. This is my mean. This is my standard deviation. So I have mu equals 1. Standard deviation is 0.70710678. If the question is asking you to round to a certain number of decimal places, if the question has an instruction to round to a certain number of decimal places, then please follow the instruction. In this case, they didn't have any instructions. So I'm looking at my original data value. It has no decimal place. I am going to round this to 1 decimal place. To find the variance, I am going to square the standard deviation. And I will round it to 1 decimal place as well, which is 0.5. The expected value of a discrete random variable x is denoted by E, and it is the mean value of the outcomes. So E is actually equal to mu. And E can also be found by evaluating the sum of x times p of x. Example 4. When playing roulette at a casino, a gambler is trying to decide whether to bet a $5 on number 27 or to bet $5 that the outcome is any one of the 5 possibilities 0, 0, 0, 1, 2, or 3. A. Find the expected value for the $5 bet on 27 with the payouts of 35 to 1. Which means that if you bet $1, they pay you $35. If you bet $10, they pay you $350. In order to find the expected value, I will need to create an event table. So when I gamble, I will only have 2 events, either win or lose. X is the profit when I win or lose. If I bet $5 on number 27, and if the outcome is not 27, I will lose $5. So on the event of losing, my X is negative 5. If the outcome is 27, then I win. They pay me 35 to 1. So if I bet $5, they pay me 35 times 5, which is $175. And then I have the probability, which is P of X. There are a total of 38 numbers on this wheel, and 27 is one of them. So probability for winning is 1 out of 38. And probability of losing is 37 out of 38. My expected value is equal to 175 times 1 out of 38 plus negative 5 times 37 out of 38. And I get negative 0.263157847. And this is in dollars, so I'm going to round it to 2 decimal places. My expected value is negative 26 cents. What does that mean? It means that if I keep playing the game, I will expect to lose 26 cents on each game on average. Question B. Find the expected value for the $5 bet that the outcome is 0, 0, 0, 1, 2, or 3, with the payouts of 6 to 1. Similar to the previous question, I will construct an event table. If I bet $5 on one of these 5 numbers, if I lose, I will lose $5. If I win, they pay me 6 times on what I bet. There are a total of 38 numbers on here, and I bet on 5 of these. That means the probability of winning is 5 out of 38. And the probability of losing is 33 out of 38. To find the expected value, I take 30 times 5 out of 38 plus negative 5 times 33 out of 38. And I get negative 0.394736821, and I am going to round it to 2 decimal places. My expected value for this game is negative 39 cents, which means if I keep playing this game, I will expect to lose 39 cents on each game on average. Question C. Which is better? A $5 bet on number 27 or a $5 bet that the outcome is 0, 0, 0, 1, 2, or 3? In order to answer these questions, we need to look at the expected values that we found in question A and B. In question A, they gave me the expected value of negative 26 cents. In question B, they gave me the expected value of negative 39 cents. A game with negative expected value is not a good game to play. But if you have to choose between the two, then we need to choose the one with less negative, which means a $5 bet on number 27 is better because you expect to lose less. Example 5. There is a 0.9987 probability that a randomly selected 31-year-old male lives through the year. A life insurance company charges $182 for ensuring that the person will live through the year. If the person does not survive the year, the policy pays out $90,000 as death benefit. From the perspective of the 30-year-old male, what are the monetary values corresponding to the 2 events of surviving the year and not surviving the year? There are 2 events. Either the person is surviving the year or not surviving the year. If the person is surviving the year, he loses $182 because he paid for the insurance throughout the year. If the person is not surviving the year, his family will get $90 as a death benefit. However, this is not net because he paid $182. So the net amount is $90,000 subtract 182, which is $89,818. Question B. If the 30-year-old person purchased the policy, what is his expected value? In order to find the expected value, I will create an event table. I have 2 events, either surviving or not surviving. My X is the profit. If he's surviving, he will lose $182. If he's not surviving, the profit is 89,818. And the last column is P of X. Probability that the person will survive through the year is 0.9987. And the probability that the person is not surviving through the year is the complement of this. So to find the complement of this, I'll take 1 minus 0.9987, which is 0.0013. To find the expected value, I take negative 182 times 0.9987 plus 89,818 times 0.0013. The expected value is negative $65. Question C. Can the insurance company expect to make profit from many such policies? Yes, because for each policy for a 31-year-old male, the person is expecting to lose $65, which means the company will expect to earn $65 for every policy on average. Range rule of thumb for identifying significant values. One of the methods to identify significant values is using the mean and the standard deviation. I have the mean in the middle. This number is mean plus 2 standard deviations. This number is mean minus 2 standard deviations. Any values within these two values are not significant. Any values that are higher than mean plus 2 standard deviations are significantly high. Any value that is lower than mean minus 2 standard deviation is significantly low. Example 6. We found that when tossing 2 coins, the mean number of heads is 1 and the standard deviation is 0.7. Use those results and the range rule of thumb to determine whether 2 heads is significantly high number of heads. I have my mean in the middle. This number is mean plus 2 standard deviation. This number is mean minus 2 standard deviations. So this is 2.4 and this is negative 0.4. Anything in between negative 0.4 to 2.4 are not significant. Anything that is larger than 2.4 is significantly high. Anything that is less than negative 0.4 is significantly low. And they're asking if 2 is significantly high. So 2 is in here. So 2 is not significantly high. We can also use the probabilities to identify significant values. X is a significantly high number if P of X or more is less than or equal to 5%. X is a significantly low if P of X or fewer is less than or equal to 5%. Example 7. The accompanying table describes the results from the groups of 8 birds from 8 different sets of parents. The random variable X represents the number of girls among 8 children. So in this table, I can have 0 girl, 1 girl, 2 girls, 3 girls, 4, 5, 6, 7, or 8 girls, and the corresponding probability. Question A. Find the probability of getting exactly 6 girls out of 8 birds. So this is exactly 6 girls. The corresponding probability is 0.111. So this is the probability of getting exactly 6 girls. B. Find the probability of getting 6 or more girls in 8th birth. Probability of x is greater than or equal to 6. 6 or more means greater than or equal to 6. 6 or more means 6, 7, 8, which means you're going to take the probability of 6 girls plus to the probability of 7 girls and plus to the probability of 8 girls. C. Is 6 a significantly high number of girls in 8th birth? In order to identify whether 6 is significantly high or not, we are using the probability of x is greater than or equal to 6. This probability, if it's less than 5%, then 6 is significantly high. If it's not less than 5%, then 6 is not a significantly high. So this probability is 0.14, which is greater than 5%, which means 6 is not a significantly high number. D. Find the probability of getting 1 or less girls. 1 or less means less than or equal to 1, which means I'm looking for the probability of 1 girl and the probability of 0 girl. So I'm going to add these two up. E. Is 1 a significantly low number of girls? In order to answer this question, I look at the probability of 1 or less. If this probability is less than or equal to 5%, then yes, 1 is significantly low. If this probability is greater than 5%, then no, 1 is not significantly low. So 0.029 is actually less than 0.05. So yes, 1 is significantly low.